All right. So you have 9 isomers for C7H16. Let's see. So we have, let's just first see the structural isomers of C7H16 here. So the first one is, you draw a straight chain 7 carbon compound. Yeah, this right here is what? Heptane. Now you don't have to write the structural formulae to find out whether they're isomers or not. What you can do is you can just name them. If the name is different, they're isomers. Then you shorten the chain. You make the main chain of 6. Put the 7th one, let's say here. So this becomes what? 2-methyl hexane, right? Then you can again make the main chain of 6. Put the 7th one here, and this becomes what? 3-methyl hexane. So this right here is 3-methyl hexane. Then you may think that you have a 4-methyl hexane. That is not possible, because if you put it here, if you think this is the 4-methyl hexane, no, this will be what? 1, 2, 3-methyl. Again, you've already drawn it. So this is not an isomer. Further shorten the chain. Put the main chain as 5. Now the 6th and 7th. So that can go as a ethyl group. Now you'll be like, Miss, can we put an ethyl group over here? Yeah, on carbon number 2. Can we call this 2-ethyl pentane? No. The longest chain will now be 1, 2, 3, 4, 5, 6. This is 3-methyl hexane, which you've already drawn. So this can't be it. Yes. So you'll be like, okay, Miss, how about we move this ethyl group on carbon number 3? Now the longest chain is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So either way, the longest chain is 5, and this becomes what? 3-ethyl pentane. I think most of you may have missed out this one. 3-ethyl pentane. Now the 5th one, let's see. You make the main chain of 5. Yes. Now the 6th and the 7th, you can put it as methyl groups on carbon number 2 and carbon number 2. Both of them on carbon number 2. This becomes 2, 2 dimethyl pentane. Now you'll be like, Miss, can we have 3, 3 dimethyl pentane? Let's see. So your main chain of 5, put a CH3 here, put a CH3 here. This becomes what? 3, 3 dimethyl pentane. Then you can also have what? 1 on carbon number 2 and 1 on carbon number 3. So you can have 1 methyl right here, 1 right here. So this can be what? 2, 3 dimethyl pentane. Now you can also have 1 on carbon number 2 and 1 on carbon number 4. So let's see, 2, 4 dimethyl pentane. Yes, so we can have this as well. So this is 2, 4 dimethyl pentane. Then you can further. Now you'll be like, Miss, can we have a 4, 4 or can we have a 3, 4? Can we have a 4, 4 dimethyl pentane? No, this won't be 4, 4. This will be 2, 2. Now you'll be like, Miss, can we have a 3, 4? This is not 3, 4. This is 2, 3, which you've already drawn. Clear? Then let's see another one where you further shorten the chain, make the main chain of 4. Now 3 carbons. Let's put them as alkyl groups. 1 here, 1 here, 1 here. So you have 7 carbons in total. Let's see the longest chain. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Either way you see, the longest chain is 4. So this becomes what? 2, 2, 3 trimethyl butane. So this is the 9th isomer. And there are no other possibilities except these. Is this clear? They ask you this in MCQs. And they literally just give you the number as options. A, B, C, D. One will say 8, 7, 9, 10, whatever. And you'll have to draw these and count these and then give your answer. Clear? Is this clear? Do you? All right. Let's move on to dichloroethane. Isomers for dichloroethane. So we have two carbons. Dichloro means you have two chloros. You can have both on carbon number 1. So this can become 1,1-dichloroethane. Yes. Or you can have one on carbon number 1, one on carbon number 2. So this becomes 1,2-dichloroethane. You can't have a 2,2 dichloroethane because that will be the same thing as 1,1 dichloroethane. So you only have two possible isomers. Clear? Then let's see trichloropropane. Let's see dichloropropane first, then trichloropropane. So let's see dichloropropane. So you have 3 carbons. Yes. So you have 3 carbons. Dichloro means 2 chloros. So this becomes 1,1 dichloropropane. Then you can have 2,2 dichloropropane. So 2,2 dichloropropane. You can't have a 3,3. Then you can have a 1,2 dichloropropane. Yes. Then you can have 1,3 dichloropropane. So these are your 4 possible isomers for dichloropropane. Clear? 1,1, 2,2, 1,2, and 1,3. Let's see trichloropropane now. So let's see trichloropropane. So with trichloropropane, let's see the number of isomers. So you have again 3 carbons, 3 chloros. All 3 can be on the first carbon. This becomes 1,1,1 trichloropropane. Then let's see 3 carbons. Then you have 1, 2 trichloropropane. Then you have 1, 2, 2 trichloropropane. Yes. Then you move it on carbon number, let's see, 1, 2, 3 trichloropropane. Then you can have 1, 3 trichloropropane. Yes. So you have 1, 1, 1, 1, 1, 2, 1, 2, 2, 1, 1, 3, and 1, 2, 3 trichloropropane. Is this clear? Do you think of any other possible isomers? Do you think of any other possible isomers that you can have? Now let's see the example, the isomers for chlorobutane. Yeah. So let's see the isomers for chlorobutane. So you have 4 carbons, Cl on carbon number 1. So this becomes 1 chlorobutane. Yes. You can move the Cl on carbon number 2. So this becomes 2 chlorobutane. Yes. So this is the first isomer. The second, now you'll be like, Miss, can we have a 3 chlorobutane? No. When you put it here, you will start numbering from this side. So it will again be 2-chloro. So there is no 3-chlorobutane. This is not 3-chloro. This is 2-chlorobutane. So there's no 4-chlorobutane either. That'll be 1-chlorobutane. So now you'll be like, okay, miss, let's shorten the chain. Let's make a chain of 3. Put the 4th one here because the 4th carbon cannot go on the terminals. Remember I told you? Now the chloro, let's put it on this carbon. This becomes what? 1-chloro, because you always name the halogen first. 1-chloro, 2-methyl propane. Do you see? This is something completely different. Now you'll be like, okay, miss, how about we move the Cl on the 2nd carbon? So this would be what? 2-chloro, 2-methyl propane. This is also different. If the name is different, they're a different compound. Clear? Now you'll be like, miss, can we do this? Can we do 2-methyl 3-chlorobutane propane? No, this is not 3-chloro. This is 1-chloro 2-methyl, which you've already drawn. Because now you will start numbering from this side. Clear? So that's it. That's all we have. There are no other possible isomers for this. Is this clear? Let's see the isomers for C5H11OH. Now you got to make all alcohols, all right? So let's see C5H11OH. So the first one, let's make a straight chain alcohol with 5 carbons. Yeah, where we put the OH on the first carbon. And this is what? Pentan 1-ol. Then you move the OH on carbon number 2. Yes, and this becomes what? Pentan 2-ol. Then you can move the OH on carbon number 3. So that becomes pentan 3-ol. Yes, so this right here is pentan 3-ol. Then you shorten the chain. You can't have a pentan 4-ol. That'll be the same as pentan 2-ol. Pentan 5-ol is nothing. It'll be the same as pentan 1-ol. Then we shorten the chain. We shorten the chain, make a main chain of 4. Put the 5th one, not on the first or the last, because it will again be a 5-carbon chain. Let's put it here. And let's put the OH here. So this becomes what? 2-methyl butan 1-ol. Yes. Then let's put the OH on carbon number 2. So you have methyl here, OH here. So this becomes 2-methyl butan 2-ol. Yeah. So you have 2-methyl butan 2-ol. Now you'd be like, oh, miss, can we have 2-methyl butan 3-ol? So that won't be 2-methyl butan 3-ol. It would be, if you keep the methyl over here, you put the OH on this carbon. OH is the more important functional group. It will get the least number. So you will number from this side. So this becomes 3-methyl butan 2-ol. Yes. Then after 3-methyl butan 2-ol, you can put the methyl on carbon number 3. And let's put the OH on carbon number 1. So this becomes what? This becomes 3-methyl butan 1-ol. Yeah. Now you'll be like, miss, can we have 3-methyl butan 3-ol? No, when you put the OH on this, it will not be 3-methyl butan 3-ol. It will be 2-methyl butan 2-ol, which you've already drawn, right? So there is 3-methyl butan 1-ol. Now, there's no other possibility with butanol. Now let's shorten the chain further. Let's make a main chain of 3. Put the other 2 carbons on carbon number 2. So this becomes 2,2-dimethyl. Let's put the OH over here. So this becomes what? 2,2-dimethyl propan 1-ol. And that is 8 isomers for this. All alcohols, these are chain and positional, right? You don't need to know functional because ether is not part of your syllabus. Any other isomer that you think we can make for C5H11OH? Anything that you think is a possible isomer? Has anyone made anything else?